All right, let's dive into one of the biggest, most mind-bending questions out there. What really happens if you fall inside a black hole? So, just imagine it for a second. You're out there floating in space, falling feet first towards this abyss. Your ship is just a tiny speck of light now. And yeah, there's absolutely no turning back. As you get closer, things start getting weird. You look at your watch and it seems to be ticking slower, way slower than the clock back on your ship. It's not your watch that's broken. Time itself is actually stretching out. It's like the very fabric of reality is coming apart at the seams. All the rules of physics you learned, everything that makes sense in our universe, it's all starting to just break. This isn't just some sci-fi fantasy. It's a genuine mystery that has the smartest people on the planet scratching their heads. And hey, figuring this out, it could be the key to everything. So let's explore all the wild and, honestly, pretty bizarre ideas about what's really going on in there. Okay, so our journey starts at the edge, at this famous point of no return called the event horizon. Now, the event horizon isn't like a brick wall or anything you could touch. Think of it more like a one-way door in space-time. The second you cross it, that's it. You can't go back. Every single path, even for a beam of light, now leads to one place, the center. And the reason you can't get out is, well, it's pretty wild. It's not just that gravity is pulling you really, really hard. No, it's that space-time itself, the actual fabric of the universe, is flowing into the black hole faster than the speed of light. It's like you're not trying to swim against a current. You're caught in a waterfall made of reality. All right, so once you're inside, what happens to you? Well, let's just say it's probably not going to be very comfortable. The effect has maybe the best name in all of science: spaghettification. Seriously, the gravity pulling on your feet is so much stronger than the pull in your head that your body gets stretched, and I mean really stretched, like into a long, thin noodle of atoms. You'd literally be turned into spaghetti. But get this, and this is kind of crazy, if you fall into a supermassive black hole like the ones at the center of galaxies, you might not even notice when you cross the event horizon. The stretching part comes much later. You could just float right past that point of no return totally fine, for a little while anyway. Okay, let's go deeper. We're heading for the very center, the heart of the mystery. This is the point where all of our physics, everything we know, just completely breaks down. We're talking about the singularity. The thing is, a singularity isn't really a place. It's more like an end point in time. It's the future you're doomed to meet once you're inside. It's where space and time as we know them just stop. And this is where things get really tricky. On one hand, you have Einstein's general relativity, which says the singularity is a point of infinite density packed into zero space. But then, quantum physics comes along and says, whoa, hold on, that's literally impossible. So when your two best theories about the universe completely disagree, it tells you something's missing. We need a whole new kind of physics to figure this out. So if it's not this impossible, infinitely dense point, then what is it? Well, one idea is, honestly, it sounds like something straight out of a movie. Believe it or not, Einstein's own math allows for a wild possibility that the center of a black hole isn't an endpoint, but a tunnel, a wormhole connecting to somewhere else in space-time. The idea is you'd go in the black hole and pop out of a white hole somewhere else, maybe even in another time. But there's a huge catch. The tunnel would collapse on you instantly. The only way to keep it open, theoretically, is with something called exotic matter, which has properties we've never, ever seen. So cool idea, but maybe not so practical. Okay, let's switch gears to a totally different idea. And this one is, well, it's a lot more violent. What if the real danger isn't what's inside the black hole, but what's right on the edge? This comes from a huge headache for physicists called the information paradox. Basically, quantum physics says information can never be destroyed, but black holes seem to just eat it. A firewall is one possible and very dramatic solution. It suggests that as soon as you touch the event horizon, you're instantly vaporized by a wall of energy, and your information gets blasted back out. So here we go again. It's the same old fight. General relativity says crossing the horizon should be no big deal, nice and smooth. But quantum mechanics says to save information, it's got to be a wall of fire. They can't both be right, which means we're missing something big. All right, buckle up, because this last theory doesn't just change our ideas about black holes.
it could change how we think about everything.
It's called the holographic principle, and it's a really deep idea. Imagine everything that makes up this room, all the 3D stuff, could actually be described by information stored on its 2D walls, kind of like how a hologram works. So what if a black hole has no inside? What if everything that falls in, every star, every planet, you, just gets stored as 2D information right on the surface, on the event horizon? The whole experience of falling through a 3D space would just be an illusion, a projection. So let's just run through the options here because they're all pretty wild. Do you get stretched into spaghetti on your way to an impossible point? Do you zip through a wormhole to another universe? Do you get vaporized by a firewall at the entrance? Or are you just turned into 2D data on a cosmic computer screen? So, which one is it? The honest answer is nobody knows. Each one of these crazy ideas comes from this fundamental clash between our two best theories of the universe. Figuring out which one is right isn't just about black holes. It's about finding the next huge leap forward in our understanding of everything. And that is a mystery I think is definitely worth solving.